A mathematical quantity is anything that can be measured or counted. The value of the quantity is its measure or the number of items that are counted. Quantities whose values do not change are called constants. In other situations, the value of a quantity can change. Quantities whose values can change or vary are called variable quantities. Take note, key concept, variables and expressions. We'll see some terms on the left, their definitions to the right of the term, and then examples on the far right. First term, variable. Its definition. A variable is a symbol, usually a letter, that represents one or more numbers. Some examples could be the variable n or x. Next term, numerical expression. A numerical expression is a mathematical phrase that contains numbers and operation symbols. Examples, 3 plus 5, and the quantity 8 minus 2 plus 5. And finally, algebraic expression. An algebraic expression is a mathematical phrase that contains one or more variables. Examples, 3n plus 5, and the quantity 8x minus 2 plus 5n. Tables are a convenient way to organize data and discover patterns. They work much like an input-output machine, a machine that takes one value as an input, processes it, and gives a value as an output. A process column in the table provides a way to understand what happens to the input values. This brings us to problem 2, expressing a pattern with algebra. Use a pattern to answer each question. Part A, how many toothpicks are in the 20th figure? So we see a pattern of toothpicks at the right. Looks like we begin with one square using 4 toothpicks for the sides, then 2 squares. They don't share any sides, so we would need 8 toothpicks, and then 3 squares, 3 times 4, 12 toothpicks. We're going to use a table, look for a pattern that relates the figure number to the number of toothpicks. So we can create a table like this. On the far left, the figure number, which we'll consider the input in this input machine. The process column that shows us what's taking place in order to determine the number of toothpicks. And then finally on the right-hand side, the number of toothpicks, or the output from this output machine. When we look at the first row, figure number 1, the process is 1 times 4. Remember, to get the output, we multiply the input by 4, and that tells us how many toothpicks. That leads us to the far right column. Number of toothpicks is 4. And this pattern continues. Figure number 2, 2 times 4 is 8. Figure number 3, 3 times 4 is 12, and so on. For any number n, the process column will read n times 4, and the number of toothpicks will be 4n. So our pattern, multiply the figure number by 4 to get the number of toothpicks. So there are 20 times 4, or 80 toothpicks in the 20th figure. Question B, what is an expression that describes the number of toothpicks in the nth figure? So we'll use the pattern from part A, and we can state there are 4n toothpicks in the nth figure. Your turn. How many tiles are in the 25th figure in this pattern? Use a table of values with the process column.